Hello, it's Mrs. Delaney and welcome to the screencast on the Group 7, more commonly known as the halogens. We're going to start as we start every lesson with a retrieval practice. So I want you to read through the questions, pause the video and come back when you've answered the questions. Okay, welcome back. What do we call the elements in Group 1? They're called the alkali metals. What do we call the elements in Group 7? They're called the halogens. What do we call the elements in Group 0? They're called the noble gases. Why do all elements in a group react in a similar way to each other? They all have the same number of electrons in their outer shell. So in Group 1, they all have 1 electron. In Group 7, they all have 7 electrons. Write a word equation for the reaction between sodium and oxygen. Right, so sodium plus oxygen gives us sodium oxide. Anything plus oxygen will give you the oxide of whatever you're reacting. What happens to the reactivity of the elements as you go down Group 1? The reactivity increases as you go down the group. Okay, so our learning objective today is to know the properties and reactions of the Group 7 elements. Hopefully by the end of the lesson we will be able to state and explain some of the physical properties of Group 7. We'll be able to state how halogens react and explain the trend in reactivity as you go up or down the group. And hopefully we'll be able to predict the products of halogen displacement reactions based upon their reactivity. Okay, so let's just have a recap about what the periodic table looks like. So the periodic table is split into vertical columns called groups, and there are 8 groups in the periodic table. So the numbers are at the top. This is Group 1, Group 2, Group 3, Group 4, Group 5, Group 6, Group 7, which we're going to look at today, and Group 0. These are elements with similar properties to each other because they all have the same number of electrons in their outer shell. Okay, so these are the 3 groups we have to study. You can find screencasts about the alkali metals and the noble gases in our YouTube site. But today we're going to look at the halogens. Okay, the halogens are coloured elements. They start off quite pale. So fluorine is a yellow gas. Chlorine is a green gas. They get dark as you go down. Bromine is a volatile brown liquid and iodine is a volatile purple solid. So you can see that they're changing state as you go down. Right, let's have a look at some of the physical properties of Group 7. Well, first of all, as we said before, they all have 7 electrons in their outer shell. And that is probably a big factor in a lot of their chemical and physical properties. All the Group 7 elements are simple molecular structures. So they're all covalent bonded to each other. They are diatomic. That means 2 atoms with strong covalent bonds between the atoms, but weak intermolecular forces between the molecules. They have low melting and boiling points, but those increase as you go down the group. Their mass and density also increase as you go down the group, and like most non-metals, they are poor conductors of heat and electricity. Okay, so let's have a look at their trend of melting and boiling points. Okay, so as you go down the group, the higher its melting and boiling point gets. This is because as you go down, the molecules become larger, the intermolecular forces become stronger, and therefore more energy is needed to overcome these forces. So this is a typical question that you might get on your exam. They show the melting and boiling points of the first 4 elements in group 7. And they want you to predict what would be an estimate of the melting and boiling point of the next element, astatine. So what you want to do is see how much it's increasing each time between chlorine and bromine, between bromine and iodine, and then go roughly the same for astatine. So pause the video now, make your estimates for the melting and boiling point, and then come back to the video and see if you were correct. Okay, so let's see if you were correct. So astatine should have a melting point of about 300 and it has a boiling point of about 340. So that means because it's so high above room temperature, it will be a solid at room temperature. Okay, so let's have our first checkpoint. I want you to read through the questions, pause the video, and then come back when you've answered the questions. Okay, welcome back. Why are all the elements in group 7, why do they have similar properties to each other? Well, they all have 7 electrons in their outer shell. Halogens are diatomic. What does the word diatomic mean? It means the molecules contain 2 atoms. How do halogens react with metals? They react with ionic bonding. How do halogens react with nonmetals? They react with covalent bonding. What happens to the melting and boiling point as you go down group 7? They increase as you go down group 7. Fluorine and chlorine are gases at room temperature. Bromine is a liquid, and the ones below bromine are solids. Explain why this happens. As the molecules get larger, going down the group, the forces between the molecules, which we call intermolecular forces, they increase. More energy is needed to separate the molecules, and the boiling points increase as you go down the group. Okay, so that is our first success criteria. So let's look at our next success criteria. We want to be able to explain the trend in reactivity going down the group. Okay, so let's look at the chemical properties of the halogens. Because they all have 7 electrons in their outer shell, they're all going to behave in roughly the same way. What they need to do in order to react is gain an electron. Now it can do that in 2 ways. It either can be gifted an electron if it reacts with a metal, right? So it's a transfer of electron to the outer shell in ionic bonding. But that can only happen with a metal. So they receive 1 electron from a metal atom and they then will become a halide ion. So when they react with a metal, they will go from being chlorine to forming a chloride ion, and that will have a -1 charge. Covalent bonding with nonmetals will have a covalent bond. That is a share of electrons, and covalent bonding happens when they react with themselves or with other nonmetals. So let's have a little look. We've got ionic bonding here where we've got sodium and chlorine. So sodium is giving its outer electron, its 1 electron, to chlorine, and that becomes a sodium ion and a chloride ion. Okay, and in the second example, where we have calcium, calcium has 2 electrons in its outer shell. So it's going to give one of those to one fluoride, but that won't be enough to satisfy calcium, so it needs to give its second one to another fluoride. So it would become CaF2. But we'll look at that more in detail when we do ionic bonding. Now here we have covalent bonding. Co meaning share, like cohabit, and valency being the outer shell. Okay, so they're sharing in their outer shell. So here we have hydrogen chloride, where the dot comes from the hydrogen and the crosses come from the chlorine. Right, so if you look around the chlorine, you have got 8 electrons in its outer shell. And if you look at the hydrogen, it's got 2. So they've both got full outer shells. Now, when it reacts with itself, each one of them needs one more to make a full outer shell. So each chlorine donates 1 electron and it forms a single covalent bond with each other. And they both then think that they've got 8 electrons in their outer shell. Okay, so let's have a look at the reactivity of all of the group 7 with hydrogen. Okay, so when I react fluorine with hydrogen, it's explosive. And it's explosive even at 200 degrees in the dark. Remember, light is a form of energy. Chlorine and hydrogen, it's explosive in sunlight, but very slow in the dark. Bromine with hydrogen, it's 300 degrees, so it's higher temperature, and we need a catalyst. And iodine is very slow at 300 degrees with a platinum catalyst. Now look at the conditions and the reactions and try and come up with an idea of how the reactivity increases or decreases as you go up or down the group. So, for instance, you might say it decreases as you go down or increases as you go up. Okay, so the reactivity decreases as you go down the group. But another way of saying that is it increases as you go up. And as you know, that is very different from group 1. It's the opposite to group 1. Okay, so let's look at why that is. Group 7 needs to gain an electron. The nearer the outer shell is to the positive nucleus, the greater that electrostatic attraction force is. There are also fewer electrons between the outer shell and the nucleus, so there are fewer electrons getting in the way of that force. And so therefore, the nearer it is, the easier it is to gain an electron. And therefore, it's more reactive. So the quicker it can gain an electron, the more reactive it is. There we go. So you can see that fluorine gets it immediately, but bromine takes a long time. So this is the reactivity of the group 7 elements. We've decided that fluorine is the most reactive. Chlorine is the next reactive, but it's less reactive than fluorine. Bromine is less reactive than chlorine, and iodine is the least reactive. So as we said, the pattern of reactivity will decrease as you go down. Right, so here's our second checkpoint. I want you to read the questions, pause the video, and come back when you've answered the questions. Okay, let's self-assess our work. So why do the elements in group 7 react in a similar way to each other? We keep asking that question. It's because they all have 7 electrons in their outer shell. How do halogens react with metals? With ionic bonding. How do they react with nonmetals? Covalent bonding. What happens to the reactivity as you go down the group? It decreases. And explain why this happens. The group 7 elements react by gaining an electron in their outer shell. We should always put that first. The further the outer electron is from the nucleus, the weaker the electrostatic attraction between the electron and the positive nucleus, and the more shielding there is between them. As you go down the group, the atoms get bigger, have more electron shells, and so the outer electron is further from the nucleus. This means that gaining an electron is more difficult as you go down the group. So hopefully you were successful with that. Okay, and that's our second success criteria. Okay, so let's look at our third one. We want to be able to predict the products of halogen displacement reactions based upon their reactivity. Okay, so let's just have a recap of what displacement reactions are. Just a sort of analogy. A cat is sitting in a chair. The tiger wants to sit on the chair. Who's going to actually sit on the chair? So obviously the tiger is the most reactive. So the tiger is going to displace the small cat and sit on the chair. Here, the opposite way round. The queen is sitting on this chair. The teacher wants to sit on the chair. So obviously, there's not actually going to be any movement. There's going to be nobody displaced because the teacher won't be able to sit on the throne. Okay, so here we have a recap of metal displacement reactions. So lithium is the most reactive. Copper is the least reactive. So if I react lithium with copper sulfide, the lithium is going to displace the copper because it's more reactive. So lithium plus copper sulfate gives you lithium sulfide plus copper. So how can we describe a displacement reaction? So use those words before and try and come up with a description of what a displacement reaction is. Pause the video now. Okay, so in a displacement reaction, the most reactive element displaces the least reactive element from a compound. That's how we describe a displacement reaction. Okay, so let's look at it in terms of group 7. So we've already decided that fluorine is the most reactive. Chlorine is the next reactive. Bromine is less reactive than chlorine and obviously less reactive than fluorine. And iodine is the least reactive. So in a displacement reaction, which do you think would displace the others? Okay, so let's look at an analogy again. So Miss Potassium is going to a party with Mr. Bromide. And Mr. Chlorine comes along. Okay? Who do you think Miss Potassium is going to couple up with? And like in a Love Island analogy. Yes, because Mr. Chlorine is more reactive, Miss Potassium will form a compound with Mr. Chloride and Mr. Bromine is displaced. So here's our reaction. Potassium bromide plus chlorine will give you potassium chloride plus bromine. Okay. Here we have a different analogy. Miss Potassium is with Mr. Chloride in a compound. Mr. Bromine comes along. Will Mr. Bromine displace Mr. Chloride based on the reactivity? No, because Mr. Bromine is less reactive than Mr. Chloride. So it will stay the same. In other words, there will be no reaction. Okay? So, which group 7 element will never be displaced by any other group 7 element from the 4 above? That's right. Fluorine will never be displaced because it's the most reactive. Which one will always be displaced? That's right. Iodine, because iodine is the least reactive. So all the others will always displace iodine. Okay, so our last checkpoint, I want you to complete the equations by writing the products. So you have to say whether you think that the halogen that is coming in to react with the compound will displace the halide ion that is already in there. So for instance, will fluorine displace iodine? Will chlorine displace fluorine? Okay, if you don't think that they will displace, then you write no reaction. Okay, so pause the video now and complete the equations and then come back and we'll go over them. Okay, so let's self-assess our work. Sodium iodide plus fluorine will give sodium fluoride plus iodine. That's because fluorine is more reactive than iodine. Sodium fluoride plus chlorine, that's no reaction because chlorine is less reactive than fluorine. Lithium bromide plus chlorine will give us lithium chloride plus bromine because chlorine is more reactive than bromine. And lithium chloride plus iodine will be no reaction because iodine is less reactive than chlorine. Potassium chloride plus fluorine will give us potassium fluoride plus chlorine because fluorine is more reactive than chlorine. Hopefully you were successful with that. So that's our third success criteria. Hopefully you understand a little bit better about the properties and reactions of the group 7 elements. Thank you for joining me for this screencast.